In this lesson, we are going to do some more trig identities, and we're just going to make them a little bit more challenging kind of as we go. There'll be a part 3 to this one as well that makes it kind of the toughest of them. So we are trying to take sine squared over cosine and somehow make it into secant minus cosine. So the biggest thing is recognizing where do you have to go. We have to make something that has a subtraction in it. And right now we don't have a subtraction. So we got to figure out what kind of a substitution, what kind of something can we do on the top to introduce a subtraction. And it's the fact that we have a square in here. It means we have a Pythagorean identity of some kind of substitution. So there's definitely something we can do with sine squared. And right here, sine squared is going to be equal to 1 minus cosine squared. Now I don't know if that's exactly where it's going to go, but a couple things that I noticed that I like out of it is we have a subtraction, which is what we want, and it brings in cosine. I know we already have a cosine, but it gets rid of your sine and brings in a cosine. So our final answer has nothing to do with sines, because even secant is some version of a cosine. So that seems like a good path, a good start to go. So we'll take the top and we'll sub that out into 1 minus cosine squared theta over cosine. All right, so then we can, because we just have a single piece in the denominator, we can break this up into 1 over cosine theta minus cosine squared over theta. And I start to see some good stuff happening because you have a 1 over cosine, which is secant. So that piece is taken care of. And you have a cosines over cosines. So one of these can cancel one of those and just literally leave you with cosine. And that is exactly where we're looking to go. All right, second one. We have kind of a backwards version of this. So we have something that has an addition, and we want to somehow combine these two things together and make that. So you do have a secant squared plus a cosecant squared. So I'm kind of looking to see if I have anything related to that. And I don't, because secants go with some tangents, and then cosecants are going with cotangents. So I don't see a great way of just kind of subbing out one for something else. But what I can do is somehow I got to put these two together. And it's the fact that secant is a 1 over cosine squared, and then plus this is a 1 over sine squared. So if I start heading that route, I can put some stuff together by making some common denominators. So I'll multiply this side by sine squared. I'll multiply this by cosine squared. And then I can put the tops and the bottoms together. So I'll have a cosine squared sine squared, because that's our common denominator between the two, and the top gets us a sine squared plus a cosine squared. And that goes away because sine squared plus cosine squared is 1. So we have a 1 over cosine squared theta times sine squared theta in the denominator. And I can bring both these two things up, so I can break them up and bring them up. And then this can come up, this can come up, because we have 1 over sine, 1 over cosine are our secant squared times cosecant squared. And that's it. All right, and then we'll have one more that has a little bit more challenging problem.